Okay, let's jump right in. Welcome to this explainer, where we're going to completely bypass those dry, dusty textbooks and dive straight into the exact high-stakes strategies you need for Cambridge Biology 9700. Seriously, we are going to transform those failing, generic answers into top-band, high-scoring responses. If you want to know exactly what the examiners are really looking for, you are in the perfect place. Let's get started.
So listen to this. We're going to plunge right into a devastating cold open mistake. 9 out of 10 candidates write this seemingly correct answer on their exam papers. The lysosome cleans up the cell. It uses enzymes to digest waste. And you know what happens? They get hit with a massive red cross from the examiner. It quietly but completely costs them the grade. Let's break down this mistake right now, before you make it on your actual paper.
We can actually diagnose this exact red pen error pretty easily. The student fell right into the ultimate generic answer trap. They missed the technical mark entirely by failing to mention the optimal acidic pH of around 4.3, and they completely ignored the syllabus-specific terminology. Words like cleans up are just way too broad. Examiners need specifics. You literally cannot just describe a process, you absolutely must link it to the biological context and use the required command words.
Notice the stark contrast here between that vague, flawed answer and a true high-mark response. The improved top-band answer actually uses precise biochemical terminology. Instead of cleans up, it says lysosomes contain hydrolytic enzymes functioning at acidic pH to digest macromolecules and cellular debris via hydrolysis, breaking them down into monomers for reuse. Do you see the difference there? It's night and day. It provides the mechanism, the exact environment, and specific data points. This is exactly what an examiner rewards.
Section 1. The High-Mark Answer Framework and Simpsons Index.
To stop making these basic errors and really conquer complex topics like Simpsons Index of Diversity, which by the way accounts for a massive 15% of your Paper 2 marks, we have to rebuild how you construct answers from the ground up. Securing top-band marks is a highly systematic process. Step 1. Top candidates always identify the core biological concept first, defining it using precise terminology. Step 2. They extract specific evidence and data from the stimulus, like tables or graphs, and they never forget to quote data points with their units. Step 3. They bridge the gap with scientific reasoning using logical causal relationships. And finally, Step 4. They refine their wording to perfectly match Cambridge Examiner keywords and command words like explain, describe, or evaluate.
I highly recommend you memorize this 4-step processing sequence: concept, evidence, reasoning, wording. Applying this exact method to your experimental data and statistical tests, like tackling the complex calculations and significance in Simpsons Index of Diversity, is literally the only way to prove you truly understand the biological engine at work. It shows the examiner you have real analytical depth rather than just superficial breadth.
Let's see how this builds by looking at another classic trap. If you just write ribosomes in your answer, you're falling right back into the vague answer trap. Top-tier answers specify 80S ribosomes in the cytoplasm versus 70S ribosomes in organelles like mitochondria and chloroplasts. Plus, it is absolutely critical to avoid the missing units error. Top candidates never trigger this penalty. When they extract specific values from a table or graph, they always include the units. Omitting the unit results in an immediate, painful mark loss in data questions.
Section 2. The Method Mark Strategy.
But what happens if you're sitting there in a high-pressure exam, working through a complex procedure, and you just miscalculate your final answer? Is all hope lost? No, not at all. Take the Biuret test, for example. It detects the presence of peptide bonds in proteins, showing a blue to purple color change. But look closely at the method mark strategy approach. Examiners will actually award you partial credit, method marks, for simply showing your procedural steps. If you select the right apparatus, make accurate observations, identify anomalies, and draw evidence-based conclusions, you earn marks for the process itself, even if the final calculation or end result is a bit off. Always show you're working.
Now, let's turn this into an active interrogation with a quick spot the error challenge. I want to test if you're falling into a really common examiner trap, confusing cause and effect. You have 15 seconds. What precisely triggers tropomyosin movement in the sliding filament model? Think about the exact sequence of events.
All right, time's up. Let's see how you did. If you suggested that troponosin moves before calcium binds, you've reversed the biological sequence, and that is a major red flag error.
Calcium ions absolutely must bind to troponin first. This binding causes a conformational change that pulls troponin away, exposing the myosin binding sites on the actin filament. Getting this sequence backward is a classic cause versus effect confusion trap that examiners specifically warn about in their reports year after year.
Section 3. Top examiner warnings and critical evaluation.
To guarantee you secure those top band marks, we need to heed the definitive warnings pulled directly from Cambridge Principal Examiner reports. This is essentially the examiner's playbook. When evaluating infectious diseases, for example, students constantly fall into the terminology context trap. A classic mistake is using the word pathogen incorrectly instead of vector, depending on the transmission method described. Examiners require your scientific terms to be highly specific to the given context. Another huge warning is prioritizing superficial lists of facts over deep, logical reasoning. Top-band answers use comparative connectives like whereas and similarly to build a solid, well-reasoned comparative analysis fully supported by evidence.
I want you to engrave these top 3 examiner warnings into your memory right now. 1. Using correct terminology in the wrong context. 2. Forgetting to check units and data in stimulus tables. And 3. Providing generic textbook facts instead of scenario-specific answers. Systematically avoiding these 3 pitfalls is your ultimate edge in the exam room. It proves to the examiner that you aren't just reciting memorized facts, but that you actually understand how to handle and evaluate complex scientific information.
As we wrap up this explainer, I want you to ask yourself this final, crucial question before you sit down for your next paper. Are you truly evaluating the living biological scenario in front of you, or are you just reciting a memorized textbook fact? Because true mastery in Biology 9700 is about applying dynamic scientific reasoning to totally novel scenarios. It's about seeing the context, avoiding those traps, and communicating your knowledge with absolute precision. Keep these strategies in mind, apply that 4-step framework we talked about, and you will be well on your way to completely cracking the mark scheme.